some of our challenges along the way, and still challenges we've been facing since like probably 2 minutes ago. I am Ken Toler. This is Jonn Callahan.
How's it going?
John's the Python guy. Built most of the tool that you'll see. And kind of started this whole thing. A little disclaimer, you see at the bottom, we've been finding ourselves saying @once numbers instead of acknowledgement numbers, so you'll excuse us if that happens during the talk. So let's go through the agenda. So we're going to talk about a little bit of the inspiration we had and why we started this project. We're going to talk about Vikings, because Vikings are cool, that's what we're going to do. We're going to talk about the components of the tool. A little bit of TCP injection overview and how it kind of relates to the AppSec side of things, the UI we come up with, goals, challenges, where it is, the environment we're setting up, a little bit of a demo, talk about where it's going, and a lot of goals. So first, we'll talk about the inspiration behind everything. John and I test a lot of .NET apps, or have tested a lot of .NET apps together, and so we noticed some things with how they interact with the database and what's going on behind the scenes. I noticed a lot of deployments with unencrypted database connections, more trusting the firewall, and being able to see that traffic, and we had some ideas about what we might be able to do with that. We obviously got some SQL injection, and so that happened. So we popped open Wireshark and tried to leverage some of those skills, and with a little luck, we saw the unencrypted traffic, and we're like, man, what would a Viking do with this? So Vikings would, probably scout, right? Okay. And we found this image, and that was pretty cool because it encompasses everything that we love: rainbows, AK-47s, and Vikings, right? They probably see all that information, do what they can with it, pillage it, and do that. And then finally, they would probably take all that information and plunder, right? Yeah. So I'm gonna let John get into a little bit of the kind of what each part of this does. I'll turn it over to you, man.
So as I mentioned, the tool is kind of broken down into 3 different pieces from a high-level ideological standpoint. So the scout piece is really the piece that's pulling all the traffic off the wire. It's going through and seeing all the TCP, it's looking specifically at TCP connections that are done, established between any client and server, not just database servers. And it's looking for, if it doesn't know what it is, it'll try to fingerprint it. Right now, all we really support is MySQL. We really focus on that initially. So we'll try and fingerprint the traffic and determine whether it's not MySQL. We'll also check to see if the connection is being established against a database that you already, or against a server that you already know to be a database server. So you don't have to worry about fingerprinting anything at all. And then it'll track all that information for you and actually house it all for you. So part of that as well is also go through and parse all the traffic. So if it knows it to be database traffic of some sort, it'll actually parse the network protocol. Say this is the request that was made, here's the response that came back. So a user login request, someone tried to log in with these credentials, a select statement was made on the database, and the associated response to that, yes, a row is found with these credentials, no, a row is not. So it's a really easy way to pull all this really sensitive information off the wire when an unencrypted connection is being established, and that was really the initial inspiration behind all this. The second piece, which I dubbed Pillage, is the active piece of the tool, where Scout isn't interacting with anything. It's sitting completely passively on the wire, just pulling things off. No man in the middle at this point, so it's just reading traffic over the wire. The Pillage component is the actual active piece that's putting traffic on the wire. What it lets you do is execute arbitrary SQL queries against a database without credentials. And this is achieved using TCP injection as its technique. We'll actually get into that. So quick 2-second TCP overview. I'm sure everybody knows how it works. Send ACK packet sent to establish your initial TCP handshake. Once your handshake is established, traffic starts flowing back and forth and tracked via sequence and acknowledgement numbers to make sure traffic is arriving in the correct order. You're not getting duped packets of any kind or anything like that. Sequence and acknowledgement numbers are predictable because they are a validation source. So the way TCP injection works is we're essentially putting a packet on the wire, spoofing the source IP, the source port, the destination IP, and the destination port. So we have a legitimate connection between a database server and a client server. A connection is established and a TCP connection is opened between the two places. Go to the next one. And then we ourselves are sitting on a subnet in which this traffic is actively flowing over. And once this connection has been established, we're putting this packet on the wire with a valid query, with a valid sequence number, with a valid acknowledgement number, making it look like it came from the client to the server. So when the database server receives this, it thinks it's a valid packet and tries to execute that query as if you were the actual client themselves. So the strength of this is you essentially don't need credentials to execute anything. You always need to be on the network in the first place, so this is much more of a post-exploitation tool. But if you're on there, you have access to everything that account has access to, and really lend some more credence to the ideology of least privilege. Don't run SA on your web server. That's probably a pretty bad idea. And that was really the idea behind TCP, or the pillage piece of that. And then the final piece, plunder, it's just your reporting piece. There's really nothing special about that. As of right now, the file type, or how the file outputs to, is very, the focus is on human readability versus any kind of programmatic aspects. So it doesn't output to like CSV or JSON or anything like that yet. It was emphasized just so that you as a person go through and easily look at all the queries that have been captured, as well as some other information, which we'll get into in a minute. So the UI. UI is it's an interactive interface. You can actively interact with the tool as it's running. At the top, it actively tracks any known database it fingerprints or you manually enter. It will track on the number of open TCP connections it's currently looking at and the number of queries that have been captured so far. So it's just a cool little way for you to be able to see, oh, it actually is picking up traffic, it's seeing all these different things that are flying across your network. Interacting with it, you have a couple things you can do with it right now. Namely, you can dump all the file or dump all the data it's parsed so far, dump it to a text file or whatever file you want. You can import a database of your own choosing. So if you happen to be doing some, you're already on the network, you already happen to know there's a database on this server. You don't have to wait for SQLViking to actually fingerprint it. You can just put it in there. That way it already knows right off the bat, okay, this isn't my SQL server. And so it'll start parsing any traffic to and from that server. And then the injection piece. So you can choose a query to run and then the IP port you want to run it against.
So once we have like all those goals fleshed out, we were trying to think of, how does this differ? How are we different from a standard man-in-the-middle attack? And so what we wanted to do, the main goals were, we want to easily read the data. We want to be able to see all that data coming back and forth over the wire without being in the middle of the connection, without creating too much of a fuss, right? We want to be as sneaky and quiet and passive as possible. And then we can take all that data offline, or even while we're there. The end goal being that we can either be on the network, or we can, this is like post-exploitation or physically on that subnet. We can drop that, leave it there, and then pick it up a week later and see what we've got, right? That's kind of the end idea there. So the initial goals were, we want to observe that passively with no interruption or very little interruption between the client and the server, but we want to be able to impersonate that connection from the client to the server without the server really knowing about it. And then from that, log all the relevant traffic, kind of weed out the noise, and then be able to put our own requests on the wire and not be so noisy as to be in the middle of the actual connection. I think you can talk a little bit more about that as well.
Yeah.
So one of the challenges, how do we differentiate all that database data, and especially from how many users you have? You have 100 users, and all that database data is flying back and forth. People making requests out, clicking on buttons, whatever they're going to do, versus all of the other junk on the stuff that we don't really care about. Or if we're trying to get all this database data, we don't want to see things in our results that aren't relevant to us. The other challenge is injecting that legitimate request as a client without breaking that connection, interrupting that connection. Obviously, TCP is built-in stuff to reset the connection, and depending on how that is implemented, will be kind of what determines that. Pillage right now, will break connections, because if you inject that as a request, the client doesn't know what to do with it, and it sends a reset packet back, and in most cases, and will reset that connection. And then with all of that data that we have, how do we organize it? Right now, like John said, it's human readable, and so we can look through it and pick it apart. But how do we make it so that we can put that into another tool, or CSV it out, or something like that that makes it a little bit more, a little easier to read. And then the big challenge is getting on that network. This is something that maybe a physical pen test, or if you break another box on that network that has a weakness, that's probably the biggest challenge there.
As I mentioned before, this is very much a post-exploitation tool. You use this once you're already on the network. So where is it now? Scout's picking up packets. It's good to go. As I mentioned before, very much MySQL focus right now. SQL Server is in progress. It doesn't fingerprint it at all, and you can't inject. It doesn't properly encode packets to the TDS protocol yet. Pillaging piece, the Great Heathen Army, actively pillaging away, which again injects SQL requests on the wire. Right now it's written in Python 2.7. Specifically because we leverage the SCAPI library for the reading and injecting packets onto the wire. And SCAPI right now only works on 2.7, hasn't been ported over 3 yet. And it also only works on Linux. That was due to some UI hack I had to do to make the raw input method in Python non-blocking, because it is blocking, which really messes up with an interactive tool. So again, by SQL, fingerprints, parses, generates packets. You can see everything going back and forth. There's a couple different queries that it breaks on currently that we got to write some custom parsing for. Same thing with SQL Server. It'll read stuff off the wire, so if you happen to know that there's a SQL Server database on the network, you can put it in manually, and it'll start parsing data as it comes back and forth. But right now, it does not fingerprint. So next on our to-do list.
So, trying to prove this, when we're sitting there and using multiple boxes, and obviously with something that is mostly with a physical attack where you're sitting on the network, or if you're trying to get between the application server and the database, it's obviously not something that's easy to set up in a home lab, right? Or you have to build these VMs, and you might have to have multiple databases. And we'll get into kind of the goals of the tool later, but as you start expanding your the amount of databases that we're going to support and kind of modularize into this, we were thinking, how do we best create a demo environment, or an environment that you can use the tool in to test different techniques or contribute to the code or whatever it might be easily. So we've always talked about Vagrant and all these new shops using Vagrant to spin up new stuff and deployment and testing environments. We thought it was a good thing to give a shot. So right now, we have 4 Vagrant boxes that are available with the tool. And those Vagrant boxes are a really simple weak application that connects to a MySQL database that's running on a separate virtual machine, and then SQLViking in its own VM on that little internal network. And what that allows us to do is we can spin all those up, make changes to the code, put it back into a virtual environment, and continue to test. We can mess with the database, we can drop it and kind of add new data. People can take their own boxes and put them into that internal network. If you have a Vagrant file or something that you want to test, then you can put that on there. You can test other applications that have, MySQL or SQL Server right now into that environment and kind of just spin it all up together. So it's an easy POC for us to allow us to be on a pseudo-physical connection inside of these virtual machines. And you just Vagrant up whatever boxes you want, and then it'll spin it all up, and then you can transmit that entire package, or if you fork it, and you can take that whole thing, give it to somebody else, and say, hey, this is what you have to fix, or whatever it might be. So it's basically SQLViking in a box. And we have some demos we're going to go through. I'm going to try to keep it as short as possible, but I can kind of show you how the environment setup goes. So this is the environment setup, and I'm going to try to skip through as much as possible if I can. Can't find my mouse. Okay. Basically, there's your Vagrant file, right? Can't see anything up there, can you? It's really small. Let's do this. Let's not do that.
I'll go into the terminal and increase the font size.
Let's do this. So I'm going to skip ahead. This thing will be 15 minutes long. But basically, you vagrant up and you give it the command MySQL, WCAP, and SQLViking, and that will tell you what vagrant box you're going to do. It downloads all of your dependencies, libraries, downloads Ruby for you for some stuff in there. Downloads MySQL, updates it, does all your apt-get stuff. Then when it gets to the SQLViking piece and the WCAP piece, it'll deploy the code to each box and allow you to do that. And then once you're in there, you'll be able to vagrant SSH into SQLViking and run as if you're on that network. The other thing that you have here is if you ever wanted to use the MySQL server for something else, or you wanted to connect another app to it that you have elsewhere, it also forwards that 3306 port out so that you can kind of do whatever stuff you want in the box on your actual host machine. So if you have a VMware or something that you want to connect to that. Yeah, sorry about that. You see it's spinning up Redis. And on the weak application right now, it's leveraging Redis and Sidekick to kind of mimic a user. So it runs a background job that just recursively kind of goes through and makes select queries and insert queries and everything, so you can kind of get some feel of how the tool works and use it that way. Yeah. So there it is. This is a really simple comment app with really screwed up font, but it's good. And this is kind of a sample output without putting it into a text editor of what's what I will give you. Sorry. Okay, so an example of one of the things SQLViking will pick up. On the left here, I've got SQLViking, and again, I'm sorry about the font here. And on the right, you have the application with the comments and everything going on. What's happening here, if it's going, you see the WCAP is being spun up, and during this time, the database is being built. The application is running, and you see that we have 39 queries that have come up in SQLViking, right? So SQLViking allows you to write that out to a file. So we're writing it out to a shared folder that's also on the host machine. So if I open that up, you can see the file has changed on the host machine here, and the text. But basically, that's all the creation queries. It's the create database. It's the insert queries. It's the select queries for the schema, the whole schema migration, and everything that's been that's been done during the creation of that database. So basically, you can get SQLViking in at the time of a database being created. You can get all of this, including what users connected to the database, what users are being inserted, or anything like that. And it'll also pick up that as you kind of go. So if you were able to get on the network at that point when a database is created, then you've got pretty much full access to everything. This again is on an unencrypted connection for that particular piece. This here is a demonstration of the user mimic function. So this is what I was talking about with Sidekick. It's the background job that's running all of those queries. So you go to user mimic, and then there's like a 5-second delay between a bunch of queries that are happening. You can see that we're getting some queries in SQLViking. It's just listening to all that traffic passively, so that right now it's unbeknownst to the user. For the demo, I've kind of got it putting out to the console so you can see what's happening if you're looking at the web server and the console. And it's making a bunch of queries. And then if we were to, once this gets finished, it'll go back to SQLViking. You see the Sidekick job is done, so that background task is finished. So we'll go back to the SQLViking piece. You see that we've actually got a comment inserted there, so we know that the user mimic has run. And again, we write that out to a file, and then you can see a bunch of gobbledygook text again. So yeah, so these are the select all users, and you can't see it, but right now there's password field, password confirmation field. So I mean, if they're encrypted, and that's one thing. But there's other useful data that might be in there. There's the insert statement that you'll see. There's all the query statements and the select all statements that are there as well. And so it kind of gives you a sense of what a user might be doing and a sense of the tool if you fork it or clone it down. Does that make sense to everybody?
Get the silence over this.
The silence is a yes. Okay, cool. So where is it going? We want all the databases, right? Right now we're MySQL and MS SQL Server. That was the thing that kicked off the research, right? So that's where everything really lies right now. But we've realized that a lot of these implementations and when you see databases going up, I mentioned this before, some of the assessments that I've worked on, people tend to trust that trust the firewall. We don't really care about the setup of the database and it being behind the firewall, whether the encrypted traffic is there or not. We have these only my application server can talk to my database server, so what's the big deal, right? With this, since there's no real man in the middle or connection, you can still kind of sit on that network and follow all this and try to impersonate this stuff, especially with some of these new NoSQL databases and Redis and Postgres and all this other stuff and legacy databases and stuff. We think that this can really benefit to see what's on the network that you're or what's on the subnet that you're on. We also want to try to put this into something like Honey Express, Raspberry Pi, or Ninja Star, something like that, so we can be kind of a physical pen test tool as well. We want to package it up for easy deployment and keep it, open source and have people contribute to it and say, hey, we want to support this database and we want to see this traffic and be able to inject into this database. How do we do it? And then obviously some of the stuff that you want to do.
Yeah, so something that I wanted to do was the Pillage piece specifically to have some pre-built queries, specifically stuff like SQL Server, like SP command shell, being able to just dump a binary to SQLViking, handle the dropping and execution of it, just to make things easier from a user perspective. Some of the other, I'll get into that later. Definitely fleshing out the fingerprinting and parsing functionality for the two databases we're focusing on right now. As I said, MySQL is almost there. SQL Server has a little bit more work to do, but it's not too far behind either. One of the big problems that I definitely foresee happening is the fact that we're tracking all TCP connections that it sees over the wire, and then that connection stops being tracked when the FIN packet gets sent, so the connection no longer is there. So on an extremely busy network, that means you're trying to fingerprint and parse every single packet that comes across the wire. So I want to build in some fault tolerance, so if you fail to fingerprint a packet 10 times after or the packet in this connection 10 times, it'll stop tracking on that connection, mark that server as not a database, and then you don't have to, it doesn't worry about it anymore. So hopefully that'll result in a significant speed increase, which really is a big concern on the Pillage part, just due to how it works. Also want to, again, preloaded Pillage attacks and queries, specifically stuff for like MySQL, some authentication downgrade attacks, which I'll show you a screenshot of in a second. A lot of automated stuff, like being able to build the schema out. So you see all these packets going across the wire, all these queries. So you should be able to automatically build out what the database looks like, pull out table names, pull out users, pull out columns, things like that. So from a user perspective, you can get the full mapping of the database just by letting this tool run and sit on the wire for a while. Eventually you'll be able to pick up all these different pieces and build it for you, so you don't have to try to put it together yourself.
The preset encrypted databases in the demo. So right now, a lot of the stuff is unencrypted, right? So we know that that's an issue. We want to kind of bring attention to that. But there's also some problems with, we want to show like how to do it right too, right? We want to be able to spin up different versions of, or different configurations of setting up an encrypted database connection inside of the demo, so that we can show you the difference of, okay, this is like really wrong, this is wrong because of X, Y, and Z, but it seems right. And then like how to do it right, protect yourself against attacks that like this, right? Or people being able to do this kind of stuff. And there's some interesting research that's coming out of that, which I think Jonn will get to. We want to make it as easy as possible to spin this up as a demo and show you how to configure things, or at least make it easier to understand like where the encryption actually comes into play and make it an easy proof of concept for clients or upper management or whatever.
So some of the long-term goals, again, SSL. Haven't done too much research with that yet. Obviously, the go-to prevention for this tool to even work is to encrypt your connections. However, if you were to load in the public-private key pairs for each client and the server into the tool, you should be able to decrypt on the fly and still be able to see the traffic that's going back and forth. I haven't looked too much into this yet, but theoretically, you could also pillage encrypted connections. You won't be able to read the response if you don't have the private key to decrypt. But if you manage to get your hands on the public key, you could still put packets on the wire and perform state-changing operations. You won't be able to exfil data, but you could XP command shell, or you could make some insert commands on the database and start modifying data. And then specifically for MySQL, I was looking into an authentication handshake downgrade attack. So MySQL 4.1 uses an extremely broken handshake protocol when a client tries to authorize to it. I haven't been able to find a detailed write-up on why it's broken. It has something to do with the hash. It's just extremely weak and very easy to break. But a lot of the MySQL 5.6, which is the one I tested against, still supports that protocol. So if you are able to inject into that handshake before it starts and tell the client to use this broken protocol, the client will respond with a broken hash, which you can go and later break on your own. So to try and explain this a little bit better, so I have a Wireshark picture here where you can see the first two packets that send that back. So the TCP connection is getting established, and the first packet that gets set out is the server to the client, indicating a bunch of information about the server itself, what kind of things it supports. But the big thing it tells you is what kind of protocol to use when responding back with your credential information. So if you're able to put a packet on the wire, a spoof packet on the wire before the server actually sends out the real one, and instead of indicating MySQL native password, which is the modern one, indicating SQL handshake 320 or something like that, I think is the name for the protocol. If you're able to specify that and send it to the client should execute that and send their credentials back. Obviously, this block is going to fail because the server isn't expecting that protocol, but the packet gets put on the wire all the same. You're able to pull the data out and then take the password offline and break it however it needs to be broken. Again, haven't done too much research on how that can be broken, but everything I see says do not use it. See the next one. Some of the long-term goals. Again, being able to capture password hashes and salts as they're being sent across the wire. I mean, even if they aren't using a weak protocol, you can still brute force hashes or perform rainbow table attacks against them. So if you're able to pull that off, you can take it offline and do with it what you will. More output formats, CSV and JSON specifically, so you can pipe this into something else if you want to use it. On top of that, also more input formats. Like if I could just take an Nmap scan, feed it into it, and automatically pull out any database instances it recognizes, then you don't have to worry about trying to go through it on your own and figuring out what they are and confining it to the very specific format that SQLViking requires when you input from a text file. Man-in-the-middle support. Definitely a viable vector, especially when you're doing the injection piece. If you're man-in-the-middling, you can modify the sequence of acknowledgement numbers as they're going back and forth. That way the client and server are both happy, while you are still able to actively put packets or inject packets into the TCP stream and get responses back. So man-in-the-middle is extremely strong. It just requires more of a setup before you can actually use it, and that's why we kind of avoid it in the first place. We try to make this as easy as it is to do for you to, you're on a network, drop it, good to go. You don't have to do anything else. So that's why we kind of put off the man-in-the-middle support for a little while until we flesh out some of the more basic pieces. And then goals with ambition is to actually rewrite the entire tool. The reason it is being written in Python is because it's just one of my strongest languages from a scripting perspective. So when I was originally looking into this, I was building a bunch of POCs and stacking POCs together, saying, oh, this does work, well, what if I do this? And I kept kind of going until I had the tool. And I got to the point where I don't really want to rewrite this. I got 1,500 lines of code. I don't really want to touch it anymore. But Python is severely limited in terms of speed. So from a pillaging perspective, I can definitely see that being an issue on enterprise-grade networks where there is a ton of traffic flying over subnets. Haven't run into a problem with it yet, but I can definitely see it being a possibility. I I picked Go out of no real, I didn't really have a reason other than it's an extremely fast language. So that's really the one I'm going to first, but yeah, I haven't done too much research onto whether that's viable or not.
So, I mean, just to kind of recap before we get into questions, I mean, the project is something that we want to kind of keep moving. It started off as like Jonn said, something that was scripted out, and then it just kind of grew and grew and grew and grew and grew and grew and grew. Now we want to kind of think, okay, well, how can we step back? How can we support more databases? How can we make it, more useful to consultants in the field? And how can we, what do people need? So we want to kind of bring attention to it and help, clients and consultants kind of realize what the issues are in their back-end databases, and then provide easy proofs of concept for exploitation so that it's easy to prove, right? That's it, I guess. And work really fast.
Yeah, actually I have one more thing. So I kind of wrote it with accessibility in mind. Within the directory, there's a database directory and a base DB file, which kind of maps out structures out the 6 different methods you have to implement for every new database you build. That way you don't actually have to touch the main code itself. You don't have to mess with that at all. All you have to do is implement a fingerprint function, a parsing function, and a query encode function. And then the SQLViking file will do the rest for you. It'll handle all the logic behind it. So as long as it's actually parsing it, or that file is parsing everything correctly, it's good to go. Which should hopefully make contributions from other people much easier, so you don't have to actually mess with the tool at all. But yeah, that was it. Any questions?
I do.
Yes.
Anyway, so
That's fine.
that's something I want to have in my workplace. So how do I defend it? Is it just SSL or?
It's not just SSL. On top of that, you have to make sure it's set up correctly. Specifically, you want to tie keys to users. That way, the keys aren't getting passed over the wire. So if a public key is exchanged on the wire, even though I won't be able to decrypt connections, but the public key I could definitely encrypt. Not definitely, maybe. Again, I have to look into that a little bit
Okay,
more.
so the keys and SSL. Oh, so you mentioned about weaker protocol, right?
Yep. Yeah, so encryption is just that's it. That's the key to defeating this. But not a lot of organizations do that because there's such a big focus on their database performing at as fast as they can. So people tend to leave encryption out as SSL slows things down pretty significantly. Any other questions?
Is there a link to SQLViking or actually look it up?
I probably should have put that in there. There is a GitHub link, yes. You pop over a notepad editor. Yeah. Here, I'll type it in. Yeah, it's not your GitHub. Wow, I can't type right now. So user Atticus, ATTICUSS. It's one of 4 repos up there. You just get to my user page and find it pretty easily. Please pull it down, mess with it, break it. Don't judge me because the code is pretty terrible. As I said before, this is kind of POC stacked on POC, as opposed to a very clear vision from the beginning. So the code is a little bit wonky. Yeah. Anyone else?
Since nobody's asking, I just have a question. I know you originally wrote in Python, right?
Mm-hmm.
So what's this Go thing? I only know the popular one. It might be popular in the hackers community. I don't know the like.
Go is another language that came out somewhat recently, but I just had a couple of friends of mine who are extremely into it, told me it's amazing and extremely fast. So
Is it comparable to anything?
Go, I haven't written it personally, so I can tell you what the syntax is like at all. Yeah.
There's a local Go meetup. So if you go to meetup and you look for Go in the LA area, they meet in here in Santa Monica once a month.
Oh, cool.
So
Cool.
Are they teaching Go in colleges or something, or university?
I
Oh,
did.
it's not official. Okay. Thanks.
No problem.
You know what I'm
that's it. Thanks for coming out, guys.
Thanks for that. You know, I first